Welcome to lesson 3, where we start to investigate this idea of definite integrals. And to me, that word definite, I'm probably going to replace it with exact when I'm thinking about these things, because we're finding exact areas now under a curve. So to do this, we're going to be combining that work we did with the primitive function in looking at that fundamental idea of how to use calculus going in that reverse direction or integrating. And we're going to combine that also with that new notation that we learnt, where it gave us a couple of primitives where we're going to find the area between. Okay, so let's go and see how to do question number 1. The key verb for all these ones now are going to be evaluate. Okay, because we're finding that definite answer for the amount of area under the curve. So in this case, we're given a boundary of between 4 and 3 that we're going to be finding the area between, and we've got this function, and this function is a bit of a simpler one. I'd always like to start by getting a bit of a picture in my head of what I'm actually doing, and I'm finding an area under this particular curve. Now this curve is actually a straight line if we think about it, 2x plus 1. So here is my straight line, there or thereabouts, 2x plus 1. And we are going to be finding the area between the value of 4 and 3 of this curve. And I'm saying curve because we're saying it for everything, but it's really a straight line. Okay, so when we go and do the working out for this question and all the next questions, we're going to do in two phases. First is we're going to integrate or find the primitive function. And then secondly, we're going to perform a substitution. Okay, so first of all, we're going to integrate this function. So we start with the 2x, we're going to raise that power of 1 to a 2 and divide by that new power. Then we've got no x there with the 1, so it's going to become just x. Now we're going to be evaluating this, so we're going to be finding those values when we substitute, so that's going to be the next phase, a 4 and a 3 into this equation. But first of all, let's just go tidy up these 2's because they cancel each other out. So it's really x squared plus x. That'll make our substitution a tiny bit easier. All right, now what we're going to do is we're going to substitute the value of the 4 in, and then from that, we're going to take away the answer of substituting the value 3 into that function. So we're going to get 4 squared plus 4, take away 3 squared plus 3. Okay, that being 20 take away 12, giving us a value of 8. Now you may say we're using those primitive function techniques, and where's the plus c? In this case, doing these definite integrals, if there was a plus c there, they would be cancelling each other out, so we don't have to worry about them for definite integrals. Okay, example number 2, very similar question. We've got our parameters we're working with our integration, our region we're going to define. We've got our function. Let's start by sketching it. Okay, this function is our nearly basic parabola. Okay, and we've got a region defined between 5 and 0. Okay, so really what this question is asking us to do is to find this area under here. Now notice I'm drawing the curved line this time. We're following the curve. That's what integration, when we do it properly, helps us do. Okay, so setting up this question, we're going to integrate this. So we're going to write 3x, we're going to raise the power by 1 and divide by that new power. And we're going to define this between 5 and 0, as the question says. So that's our integration phase. Again, I'm going to tidy it up a little bit just to make my substitution easier, taking a 3 from both top and bottom of the fraction. Okay, so now for my substitution, I'm going to get 5 cubed, take away 0 cubed. It's going to leave us with 5 cubed, or 125. So that says the area under the curve between 5 and 0 is 125 units. Okay, question 3, very similar example. Got a bit of a different function here though, negative parabola. Still between 2 and 0 is what we're going to be investigating. So let's go and draw this negative parabola in. It's an actual reflection of the last question actually. But this time we're going to be going between 2 and 0. Okay, so essentially we are finding the value of this region here. Okay, let's see what happens when this question plays out. I've got minus 3x. I'm going to raise the power by 1 and divide by that new power. I'm going to investigate between 2 and 0. Okay, this time we're going to get negative x cubed, taking that common factor of 3 out. Okay, so now all we have to do is, again, substitute. So it's negative 2 cubed minus negative 0, if such a thing, cubed. Okay, this is where we're going to get something different, because negative 2 cubed is not 8, but it's negative 8. Alright, so when we think about what's really happening here, we can't really have a negative area, but that value is a negative value. Now, the reason behind this is because that curve is the curve's lying under the x-axis. So this is something that's going to be super important for us later on. Any bit of area under the curve that goes up to that x-axis that's underneath is going to give us a negative value. That's going to be super important to consider when we do other more difficult questions later on. Okay, question 4, we're asked to again integrate. We've got our function and we've got those two values we're going to be looking between. Let's draw our curve. Okay, basic cubic function, positive direction, and we're going between 1 and negative 1. Okay, so what we're really asked to do is to find the area under here and the area under here. Alright, so this is going to be a bit more of a difficult question, or a bit more added spice to it. So let's see what happens. Again, same process, integrate, or go back to finding that primitive function again. We've got our x, we're going to raise one power and divide by that new power. And the values we're going to be substituting are 1 and negative 1. So, first of all, I've got 1 to the power of 4 divided by 4, take away, negative 1 to the power of 4 over 4. Alright, so obviously what's going to happen here, we're going to be getting a quarter, take away 1/4, because this value up here is going to become positive because it's an even power. Alright, so essentially what we've got is an answer of 0. Is that right? We can't have an answer of 0, can we? Has anyone got it yet? It's because this area has a value of 1/4 and this area has that value of 1/4, but it is underneath, so it's really a negative value. Alright, so if we're just evaluating this integral, the answer is going to be 0. If we're finding the area, things might change a bit. Alright, nice quick set of videos for today, so you can go off and do your practice questions. Remember, try and do most of your practice work in terms of textbook practice before you attempt that quiz.